Okay, I'm gonna walk around just for a minute just to see where we are. I want to get a feel for how you guys um, are coming along with these problems, and I'll go over the detail with you. So I'm staying multi-filter theory to you eventually going to work towards some for one. Plug the order there. By three, because eventually you want to solve for one, so might as well just multi-filter by three. Eventually, yeah. So multiply by three first. Before the cube root comes up, that's an easy equation for you to plug in and solve for that. Yeah, for clear, solve for C. Negative theory. Substitution is typically more complicated. If you can't do power rule, if it's like, like something that's more complicated with this, like that will probably be power. That would probably be substitution. But something that's like there's one variable that's like, that would be. Solved 8. So here, I see this. And you can plug -1 here, so. Yeah, and then you put it back to here. Solve for it, and then you should answer choice B. Plus the. Cross the line. That's So this is not one of the one. That's just one. Okay, that's just probably right. If the variable is not in the denominator, we want to just can't force it there. Okay, that's something we probably. It's long again. Yeah, I know. Please load the best. And it's so big, the two shows are saying this and so so much sleep. Okay, part A looks pretty good. If I can just walk through each of the steps with you. I think it's good that we're trying it on our own to see where we're stuck or where our potential issues are going to be. But okay, so number one, we start off by cross multiplying, right? Okay, so when you cross multiply, you want to see if your dx and dy's are in the right place, then they are. And then next we have to ask ourselves, do we have full separation variables? And we do. X is on the right, y is on the left. And there's no need to move anything else, right? We're ready to go. Y is in the numerator, so what rule do we use on the left side? Power rule. And the right side is also power rule, right? So we only do natural log if it's 1 over y, but this is not what that looks like, so this is power rule. Okay, so we go through power rule. Eventually, we have to solve for y. Eventually, we have to solve for c, but let's just see if I can do some cleanup along the way. So the -2 and 2 cancels out. That y cubed over 3. I mean, you can solve for c anytime you want, but for me, I want to try to clean up the equation before I solve for c. So here, I know I have to solve for y, so let's just go ahead and move things away from that left side as much as we can. Okay. The -2 and 2 cancels out. I got to distribute that 3 through. Now we could say 3c, but we know that 3c is just some constant. So y cubed is equal to -3x squared plus c. I'm sorry?
Why'd you put it through that?
Over here.
Yeah.
Just to indicate that I want to distribute through both sides of the equation. Because whatever I do to one side, I got to match that same process on the right side so that I'm maintaining balance. Okay. So some students were taking the cube root already, which is fine. But for me, I feel like I would rather solve for c at this stage before the cube root shows up. That way it just feels easier. I don't know. That's but if you solve for c after the cube root shows up, you're going to get a different c value than me, but eventually it'll still come out correct. So but I'm going to just at this stage pause my process of solving for y and move on to solving for c. Okay, so 3 goes in for y, -1 goes in for x.
So once I have 30 for C, I'm going to take that C value and put it back where I started making the substitution. And finally, we can do what? Take the cube root. Now, when we do the cube root, does plus or minus show up on the right side? No, just even roots, right? If it's square root, fourth root, sixth root, then yes. But if it's odd roots, you just leave it alone. There's no plus or minus. Okay, number two, we want to, sorry, answer choice B here. Right? All right, number two, we know we have to rewrite the y prime, but it just feels a little bit messy having to deal with that fraction. So, but we can though. We can say dy over dx over 3 minus x is equal to 6y. What we can do is we can just pull this dy dx out in front of this fraction because it's in the numerator. So we can say dy over dx times 1 over 3 minus x. Or we can pull that y prime in front ahead of time. If you want to do that, y prime times 1 over 3 minus x. And then turn that y prime into dy dx and then put it back together into one fraction. Eventually. Yeah, you can. Yeah, there's multiple ways, but just make sure that we're going to end up in the same spot. But yeah, you can cross multiply first and then change that y prime to dy dx. Sure. But I'm going to cross multiply at this stage here. Okay, are we in agreement with this stage when we have our dy dx's lined up? Now, there is something, let's see, do we have full separation of variables, x's together and y's together? No, there's one thing out of place. What do we need to move?
The 6y.
Now, the 6 and y look like, I mean, they're obviously next to each other, but are they connected to each other in a way that we can't separate them? No, we only have to move the what? The y, okay, just the y. Now, if it was a y minus 3 or, sorry, y minus x or x minus 3, if y was in a set of parentheses with another term, then we're forced to keep that together. But the 6 and the y, they don't have to stay together. We can move that y without the 6. Okay, they just happen to be next to each other. Now, if I wanted to move, let's say, the 3 minus x, then the parentheses has to go together since that's in a set of parentheses. So the y, I'm sorry, the 6 is where it should be, so we'll leave that 6 there. We only want to move what's necessary to the left side. We want to keep that left side as minimal as possible. Now do we have full separation of variables? X is on the right, Y is on the left. Okay, so now we're ready to take our integral here, integral notation. Left side is just what? Yeah, 1 over y is natural log. How about the right side? I don't think we need to use substitution here. What can we do? Yeah, let's just distribute, and then we have two separate terms, and we should do power rule for these two terms, right? I know that I've been saying if you see parentheses, do use substitution, but only if the parentheses is preventing you from expanding out, then you'll go to use substitution. But we should always look to see, can we just clean up and get rid of the parentheses on our own?
Would use substitution still work?
It wouldn't work.
Yeah.
Yeah, it wouldn't work. So that's why we always say that we always want to try expansion first, because otherwise, if we try use substitution, we're going to end up stuck, not being able to go anywhere. So yeah, I feel like use substitution can cover all the scenarios. It only covers scenarios that power rule doesn't handle. Okay, so we said left side is natural log, right? And the right side, 18 turns into 6x becomes plus c. Okay, I'm going to solve for y first. Raise both sides, e is the base. I can also reduce this along the way as well. All right, so we know e and natural log will have a way of canceling each other out. I can separate that c away from the rest of my expression with e to the variable times e to the c. We know e to the c will just become c. We can pull the c out in front. We can drop the absolute value. The plus and minus get taken in by that c value. Okay, we have one more thing left to do, and that's just do what? Solve for c. All right, so the order pair is given to us. 0 in for x, 2 goes in for y. The nice thing is that the 0 goes in for the x. It's going to wipe out those exponents here. E to the 0 is 1. C equals 2. Now we put that back in. Okay, let's keep going. 3. Okay, try number 3. I'll come around and see how we progress, and then I will go over each problem with you, but I wanted to give you guys a couple minutes to get started just so I can see how you're coming along.
right back. I think I've had that.
You can see, right?
If you saw C in a different spot, you would have a different C value, but at the end, it should still agree with that 12. Oh, that one should go from here to there. 36. Or did you do something?
Oh, yeah.
Okay,
So
that must have my
completely messed up.
Okay, so
6 squared.
but you had the right idea, so proceed.
Yeah.
I saw proceed in a different order, but ultimately. That's right, yeah. You got a different C value because you solved it where I did, yeah, so I did it before, so that's why. But ultimately, that's really normal. To explore over two. Oh. So it's going to something on that. Some shit are terrible, some are some. So we should keep the value exact, so no decimals. That's fun. That's fun. Good. Good job. Good. That's fine. Just divide it over. So it'll be E over. Just the. Okay. People can face. Sure, that's fine. So now multiply through by 2, solve for y, and it's sort of x right. Okay.
Okay, I'm going to work through number 3. Most of you guys have been doing really well, so keep going. Okay, at this stage, before the square root shows up, I find it easier to just go ahead and solve for c, get that out of the way, and then bring in the square root at the end of the problem. I will say this, if you are solving for c at a different point than me, you are going to get a different c value, which is fine because ultimately in the end, as long as the answers match, the c value doesn't really matter. Because if you're solving for c at an earlier or later stage than me, the c value may be different. It's ultimately what we end up. As long as we end up in the same place, that's okay. So some students feel like they're doing something wrong when they get a different c value, but that just potentially means that you're solving c at an earlier or later stage than me.
This certain, I may think of something else.
Now we know that when we take the square root of an equation, the plus or minus will show up. There's two different functions here. How do we know which one to choose? Not the x value, the y value, right? The y value is going to tell you what sign to choose. If the y value is positive, you choose the positive. If the y value is negative, you choose the negative. Number 4. dy and dx's are lined up nicely. There's one thing out of place is the y, so divide y to both sides of the equation. Full separation of variables. We can move on to our calculus step. Left side is natural log, right side is power rule. Okay, raise both sides. E is the base. Separate the C, each of the C from the rest of the problem. We know that's just going to be C that we can push out in front, drop the absolute value. Okay, one more thing left to do, and that's to solve for C. Take the order pair, 3 and E. 3 goes in for X, E goes in for Y. Reduce that, so that's E times CE to the 9th. We want to divide this over, we want to get C by itself. Okay, the way we can reduce it is there's 9 E's below, there's 1 E above. If I take 1 from each side, I have 1, the E goes away, but then there's 8 E's left in the bottom. So we can either say that C is equal to 1 over E to the 8th, or we can have it E to the negative 8. Okay. So now we insert back into our equation, and for our C value. Sorry, x cubed over 3. I need to hold on to my x, sorry. So there's a lot of different variations that you can leave your answer and that will all be correct. So this is one variation. You can also bring that E up to the top, make it E to the negative 8 times E to the x cubed over 3. That's also valid. You can also merge those two exponents together with one base. This is also valid. So any of these options are fine. It's just good to know these different variations in case it's a multiple choice question on the AP exam and you have one version and the options is showing a different version. To be able to get from your version to their version is what we need to be able to do. Any questions? Okay, next. So we see some variables that we don't recognize, right? Instead of x's and y's, we have t and w, but we said that whenever we're solving an equation, differential equation, if it's not x and y, it's always going to be time and something else. In this case, t is our x and w is our y. So what can we rewrite w prime as? Good, dw over dt, good. Sorry. we cross multiplied. dw and dt are lined up. This is where they need to be. dt on the right, dw on the left. But do we have full separation of variables? We already do, so there's no need to move anything else. We're ready to move on to our calculus step. So sometimes after you cross multiply, you're ready to go. Other times after cross multiplying, you may have to still make some more moves to get full separation. It just depends on what the problem gives you. Okay, left side is what?
Power.
Power rule. Right side is, okay, and our u value being what on the right side? 2tq. Okay, it's going to take a little bit longer to get through that right side, but we'll take our time with it. Guys, I know this is a long process with these problems, and you may be concerned that, wait, if I make a mistake early on, then that's going to mess up the whole thing. I'm going to get my equation wrong, get the C value wrong. I'm looking at your process. So if you make a small mistake, I may still give you majority of the credit because you understand the process. You may make a mistake here, but I'm gonna give you points because of what you show me, of what you understand. Okay, so don't be so worried about that. It's not all or nothing. Okay, so I care more about your process than your answer ultimately. Okay, what do we see? E squared goes away. I can push out a what? 1/6. Okay, so this should be nice and clean, right? That 1/6 is out of the way. Do we have a rule for secant squared? Not natural log. That's one of our original rules, right? We know tangent's derivative is secant squared, so the antiderivative of secant squared is just tangent, right? Just tangent. All right, do you guys remember this rule? Tangent of u is secant squared u times u prime. So if the derivative of tangent is secant squared, so then the antiderivative of secant squared must bring us back to tangent. Okay. Okay, let's bring back the original variables. I'm going to choose to get the 2 out of the way first before I solve for the C value. So it does 2 things for me. It allows me to have an easier equation to solve for C with, and also I know I have to eventually get rid of that 2 anyway. So I'm cleaning up the left side along the way as well. So I'm doing kind of 2 things at once: cleaning up the left side and making it easier for my C value to be plugged in with. Now 2 times 1/6 is what? There. We can, but 2 times C is still a what? Still a C, right? So we should leave it as a C. Right, so at this stage, before the square root shows up, I feel like I'm just going to go ahead and take care of my order pair, since it's an easier variation at this stage. Sorry, not X and Y, right? X 0 goes in for what? T, -4 goes in for W.
I'd take myself.
Okay, so tangent of 0 is 0. Right, so 16 is C. Take our C value, put it back where we started making the substitution, and then we're almost there. Plus or minus shows up. So I have a positive square root and negative square root. Which one do I choose?
Negative.
Because my value is negative. Yeah. Okay, so tomorrow we'll finish up the last one, and then we'll also start working through our test review worksheet. Okay, all right, come get your phones. Mhm. Yeah, go ahead. Sure. Okay, great. Thank you.